Good afternoon, everyone, and welcome to our second talk for our afternoon session here at PyCon AU 2025. I would like to introduce Sarah Reichelt. Sarah has been programming since before most PyCon AU users were born. And while she may not consider herself a teacher, she literally has written the book on macOS development for macOS newbies, well, 4 books actually. Sarah's passion is trying to get more people writing apps for Mac itself. So her latest book, Escape from Tutorial Hell, helps people get over that next hurdle from beginner code to developer in your own right. Sarah Reichelt.
Thank you very much. Oh, good afternoon, and thank you for coming to my talk. I have to say, but I feel a bit of a fraud standing up in front of you Python people because I'm not much of a Python person. In fact, I don't really use Python very much, except every December when I struggle with advent of code. But give me a few minutes to explain what I do, and then you'll understand why I'm here. So, in my day job, I grow yogurt-like bacteria for use in making cattle feed. And among my roles in that job, I am in charge of the process control software, which is mostly JavaScript, no JS, but it does have a little bit of Python involved. As with any agricultural job, this is seasonal, so I do other things. I do consulting programming, mainly web apps. If any of you have ever bought any furniture at King Living, you will have seen the showroom staff using my software. I also write apps for Mac and for iOS using Swift. So, I'm not really a full stack developer, I'm more an untidy heap developer. Along the way, I learnt that I really like writing books. So this started when I was asked to contribute 2 chapters to an existing book on Swift UI. And then I wrote 2 more books specifically about macOS app development. One's for total beginners, and the other is for people coming from iOS development. My most recent book is called Escape from Tutorial Hell, and that's why I'm here today. The examples in the book all use Swift, but the concepts are universal and can be applied to Python or to any programming language. So, what's the problem? Well, you learn to code by learning the building blocks. You learn how to use variables, how to use loops, how to write functions, how to write classes. But then you get out into the real world, and things are a bit different. You have to work on a complete project, and the gap between the building blocks and the projects just seems enormous. It's like one of those websites that tries to teach you how to draw an owl. You know, draw a circle, draw another circle, and now draw the rest of the owl. But you're stuck in tutorial hell because you don't know how to draw the rest of the owl. So in this talk, my goal is to provide you with some tools for making that jump from tutorials to real-life projects. And I have 4 main steps I'm going to follow along the way. Project design, project structure, documentation, and of course, we've got to discuss using AI. So the first is project design. Now, we all love coding, so it's very tempting to start by coding. But that's the wrong place to start. Start by thinking. Firstly, the high-level decisions. Well, first, what project are you going to write? Then, what platforms is it going to support? What language are you going to use? What frameworks are you going to import? And does it have a user interface? If so, what's that going to look like? So choose your project options, and for the rest of this talk, I'm going to imagine that I've been asked to write the back end for an online store. So the platform is any web server. Given my audience today, the language obviously will be Python. And for the frameworks, we'll choose a server and we'll choose a database. Now, this is a back end, so there's no GUI, but if there was, I'd stop at this point and sketch it out. It doesn't matter how rough your sketches are, that visualization will really help you design the rest of the project. So now what are the major functions of our project? I'm going to start breaking it down into chunks. So we start off, we've got the server component, we've got the database component, and then we've got the APIs for communicating with the front end. Let's keep going. The APIs, there's three main blocks of APIs, dealing with users, dealing with the products, and dealing with orders. So already, we've taken the monolithic project and we've broken it down into chunks. Now, if you're an experienced developer, you've written this sort of project before, that may be enough for you. You may now be able to look at each of these chunks and think, I can visualize how to do that. But that's fine if you can't. Just keep subdividing. Let's go into the database section. So we need to be able to create the database. We need to be able to add the tables. We need to be able to save data. We need to be able to query the data. So the goal here is just to keep subdividing the tasks until you feel comfortable with each of those tasks. This next step may surprise you. Step away from your computer. Go for a walk. Have something to eat. Get a good night's sleep. I guarantee you, when you come back tomorrow and reread your plan, it will become better. So this is not a coding talk, so I'm not going to talk about the code, but I am going to talk about how you structure the code. When we're learning to program, the code that we write is one-off code. We write it to demonstrate a point, or we write it to complete an assignment, and then it's gone. In the real world, you'll work on a project that could last for years. So you have to write code that you, or another developer, can navigate and can read. Then you have a project that you can maintain. The main aid to navigation is files and folders. Divide your code up into separate files and put these files into folders so that you can find what you're looking for. In our store example, we have orders to process, so I have an orders folder. Inside the orders folder, I have a payments folder. And inside the payments folder, I have a file for each payment method. Now, if PayPal changes their API, I can find where that code is and fix it. Or if we decide to add a new payment method, I know where that file should go. Basically, each file should only contain code responsible for one task. We need the code to be readable so that when we come back to it, we can work out what it does. Martin Fowler, in his book on refactoring, wrote, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." Now, I think he may be overestimating fools, but he has a point. Don't write clever code. Write readable code. Complex one-liners look really impressive, but they'll waste your time later when you're coming back to try and find out what they do. Keep your functions short. My rule of thumb is that if a function extends over more than the screen, it's got to be split up. I never want to scroll to read a function. And finally, use a linter or a formatter to keep your code style consistent, as that'll really increase readability. Next up, naming. And to paraphrase a joke that goes around the internet, the hardest problem in computer science is naming things and off-by-one errors. So when you're naming things, you have to remember that you're going to be reading this code maybe in a year's time, maybe in 5 years' time. And while it may seem very efficient now to use a short name that saves you a few keystrokes, it's very inefficient later when you're trying to remember what it does. Remember back in school when you learned grammar? Or am I the only one old enough to have learned grammar? Those rules can apply to naming too. Variables are nouns, username, total cost, product size. Functions start with verbs, doing words like process order, save password. Since code editors will all help you autocomplete, there's no excuse for not using long and descriptive names to make your code more readable. Here's a terrible example. Now, it may have been quick to write that, but imagine coming back to that in a year and trying to work out what it does. I mean, the only thing I can say in its favor is it doesn't use foo as a variable name. Now here's exactly the same function, only with good names. And each line reads practically like a sentence. So which one would you rather be looking at when you're reading somebody else's code? The other thing to remember about naming is that it's not a one-off task. It's something that is a live part of your code you've got to keep working on. If you come back to your project and something is hard to understand, think about how you can rename it to make it easier to understand next time. And if what a function does changes, change the name to match. Still on project structure, one file that I add to all my projects is a notes file. I use Markdown, but it can be text or anything you like. I work on multiple projects at a time, so this is to help me get back to every project. So I'll write what I'm working on now or what I'm going to work on next. I'll list the known bugs. I'll say my future plans, for version 2, 3. And I'll give links to anything that I think might help me. Just whatever I think I need to get back up to speed on that project as fast as possible. And finally, as far as project structure is concerned, source control, which these days basically means Git. So Git is a tool that has saved me many, many times. It's like a magic time machine. And if you save snapshots of your code, you can always revert when you've totally broken everything. And if you connect your code to one of the big providers, GitHub, Gitbucket, Bitbucket, GitLab, whatever, then you get an offsite backup and you get the ability to run your code on any computer, which is really useful. So if you're not familiar with using Git, this is one place where I recommend you do go back and do a tutorial. The next step on my escape route is documentation. And this may sound obvious or boring, but learning how to read and write documentation effectively is a vital skill. Firstly, every programming language has its own documentation with its own style. So you need to spend some time learning your way around this. Learn how to navigate, how to set the version number that you're working with, how to follow the links, how to search. If you spend some time early in your project to learn how the documentation works, you really save time in the long run. Depending on your editor or its extensions, you may be able to have some of this documentation locally as well. And that's really good because you can see the help without having to interrupt your workflow to get out into the website and look for it. So if that's a possibility, enable it. The other aspect of documentation is what you write. And this will mainly be in the form of comments. Now, some people say if you use good names, the code is self-documenting and you don't need to add comments. Nope, there's a certain amount of truth in that, but comments can add more value. Here's an example of a function with bad and unnecessary comments. Basically, every comment is just saying what the next line does, but the lines have good enough naming, so that's useless. So in fact, all these comments are actually making the code less readable by adding noise. This is the same function, and I've stripped out the boring, useless comments, and I've added some new ones. Firstly, we have a to-do reminding me of an optimization that I want to do. And a lot of editors can format or gather to-dos or fix-me's in a useful way, so that's a comment that's used as a bookmark. My other comment is one that's giving more information about how the returned data is structured. So, don't comment the what, comment the how or the why, or use comments as bookmarks. My final recommendation for documentation is to save code snippets. You can use a dedicated snippets manager or a text file or anything you like. I don't actually recommend using a bunch of sticky notes, but that just seemed like a good graphic to use. It's so frustrating when you know you've seen a way to do something and you can't remember what it is. So whenever I see something cool online that I think one day I'm going to need that, it goes into my snippets manager. And if I've spent ages researching how to do something, it goes into my snippets manager so I don't have to do that research again. Okay, finally we get to AI, which, about half the talks here have been about AI. So I'm not going to go into any details of why you should or whether you should. I'm going to tell you how I use AI and how I find it helps me. I started using GitHub Copilot about 2 years ago. And at first I just used it like a super code completer. So we're all used to the code completion where you start typing a variable name and it fills it in for you. But GitHub Copilot would go further than that. It would finish the line, or it would even suggest another line. If you use good names for your functions and variables, Copilot can extrapolate from those to suggest more code, which has the added benefit of encouraging good naming. AI is great for explaining code that you don't understand. I had a Ruby script that was generating all the different formats of my book. And I don't do Ruby, so I didn't know what I was doing. So I asked Copilot to explain it to me, and it took me line by line through the code and showed me what each of the lines was doing. It's really good. Another use is reminding you of syntax. Now, when working with JavaScript arrays, I can never remember all the different array functions. Is it splice or split or slice or I don't know. So I'll write a comment, get the last 3 elements of this array or delete element 4 of this array. And when I press return, Copilot provides that syntax for me. And yes, I should put that into my snippets manager. Finally, I use AI for generating sample data. This is particularly good if I'm designing an app with a GUI and I want to see how it looks with some user data already in place. So after using GitHub Copilot for a while, I moved on to using the Cursor AI editor. This is a fork of Visual Studio Code with AI built into it. And the benefit of this is that as well as doing everything Copilot does, it can access the entire project, editing multiple files at a time, and even adding new files if it needs to. And it adds a chat-based interface option for longer form queries. Now, I think probably that GitHub can do this now, but it couldn't at the time. Anyway, I found this to be great for filling in the blanks in my expertise. For example, I recently changed my website at troz.net to use a different static site generator. And unlike the ones I'd used before, this one didn't come with pre-built themes. So when I'd added all my content and set up the navigation, I was left with this rather ugly site. And I thought, now I've got to get into the CSS, but I'm not a CSS expert. So then, of course, it occurred to me to ask the AI to generate my CSS. So I pointed it at my project folder and gave it this prompt. Create a responsive CSS theme with light and dark modes. It should have a header with navigation, a footer with links and copyright notices. The home page is a list of blog post summaries, and each post has its own page. The site is mainly text with some images. So it didn't get it right first time. It took me maybe 3 hours of asking and reverting and adding suggestions and asking for more features and tweaking the colors and all those sort of things. But finally, it came up with this, which I was very pleased with. So the AI had allowed me to take a step back. And instead of operating as a mediocre CSS developer, I was a designer who was talking to a very patient CSS developer. And while I could have done this myself, I would have got stuck in how to do instead of being able to focus on what to do. Which leads me neatly onto this rule. I don't know who wrote this, so I'm afraid I can't give credit, but I love it. Never get an AI to write code that you couldn't have written yourself. This just feels right to me. The AI is saving me time by filling in the blanks, but I could have done it all myself. It just would have taken longer. I could have written all that CSS, and I can write code without super autocomplete, but the AI makes it faster and easier. And I still know enough to know if it's right or if it's hallucinating. Here are my tips for working with AI. Provide context. Now, a lot of people have discussed context in this conference so far, but the more information that you give the AI as part of the prompt, the better information you're going to get back. So point it at websites that deal with the issue you're asking about. Tell it what files you're looking at. Select the particular function you're having a problem with. Give it all the help you can so that it can help you. Iterate, like with my website. Doesn't get everything right first time. Sometimes it gets dead wrong. But reword the question, or just ask again, you'll get a different answer. And if it feeds you something that creates an error, give it the error and say, fix it. Use a new chat for each topic. And this is kind of the reverse of point one, because we want to clear the context. So the great thing about chats is that you don't have to reiterate everything. You can ask follow-up questions, and it knows what you've discussed earlier in the chat. But when you're changing to a totally new topic, you want it to forget all that stuff and start from scratch. So close that and open a new chat. And finally, don't hesitate to ask it to explain itself. Don't just accept what it says. Ask it if you don't understand. So that's my escape route. 1, project design before you start coding. 2, project structure so that it's readable and maintainable. 3, documentation, existing documentation and your own. And 4, using AI can be really helpful, but check its work. And finally, I want to emphasize that I'm not opposed to tutorials. I do tutorials. I read articles and books. I watch videos all the time to keep up to date. The problem is making that initial jump from tutorials to projects. But once you've escaped, never stop learning. So, thank you for listening to my talk. If you'd like to contact me, my website is troz.net, and I'm at Troz on Mastodon. And if you'd like to buy my book, come up and grab one of my cards that has a QR code with a special PyCon discount. And I'll put more of these out on the sticker table too. Thank you very much.
Thank you very much, Sarah. What a wonderful talk. How insightful on how to do things with confidence and stability.
The things I do to get a mug.
The things we do to get a mug, yes. The weather here is quite muggy indeed. So, Sarah, thank you very much on behalf of PyCon.
Thank you very much. Yay.
Once again for Sarah. Friends, we do have some time for any questions. Was there anyone that would like to ask any questions of Sarah this afternoon?
Oh, that's my son.
It's important to have communication and familial relationships to be able to.
Okay.
Are you proud of me? No.
Yes, I am. Very. Was that the question?
When you're breaking down into your project structure, how small do you go for those files? Like, some of them seemed like they might only just have a single function per file. Do you find that's tedious? Do you then kind of move those up a level and group a few of them together, or do you just run with that?
When I'm writing in Swift, I have a line limit. I don't like to go over 300 lines in a file. I find when I'm writing in other languages that is too limiting, particularly in like a client-side JavaScript where I don't want it to be rushing off to the server every time, so I'll have much longer files. But yes, we kept breaking down the tasks, but a single file could be a super task rather than each of the subtasks.
Fantastic, thank you. Do we have any more? Yeah, one more here.
Yeah, thanks for the talk. I like that you said don't use AI for something that you couldn't have written yourself. Actually, in my case, I have to admit, I written like a package, and I have no idea how it works. but I was all interested is I know the output, so I made sure that all the tests pass, but I don't know how it works. So I don't know. And actually, maybe a lot of people will be doing something like that.
Look, I think we all do that to a certain extent. I mean, none of us are writing machine code. We're all taking in stuff that we don't know how it works, whether it's Python itself or a framework or anything. So at some point, you've just got to trust that the maintainers of whatever that is know what they're doing. But you're responsible for you code, not for what they code.
Excellent. We have time for probably one more question if there were anything further. Of course, Sarah will be around for the rest of the conference, and we very much appreciate your time this afternoon, and we'll see you back shortly. Thank you.
Thank you.